Okay, so today in class I started with a problem, a stoichiometry problem, where I gave you that this equation where you have ammonia treated with carbon dioxide producing NH2CO and liquid water. And I asked if you started with 637.2 grams of ammonia and treated that with 1,142 grams of carbon dioxide, how much of this product would be formed? Three things you have to do here. The first thing you have to do is figure out what the limiting reactant is, and then you can figure out how much of the product we've produced. Finally, the third part of the question for me is how many grams of the excess reactant are left over. So in class I was giving you two ways to go about this. I'm going to start with the BCA table method, and then I'm going to show just the straight up mathematical method. Alright, so a BCA table. The B stands for before. We start with the balanced equation. So 2NH3 gas plus carbon dioxide yields NH2CO plus H2O. B stands for before, C stands for the change that happens during the reaction, and A stands for after. Before you start filling in the before change after table, or the BCA table, you have to make sure that everything you write in the table is in moles. So I leave a little sidebar for work over here. My first thing is going to be to convert 637.2 grams of ammonia into moles of ammonia. And 1 mole of ammonia is 17.03 grams. That gives me 37.42 moles of ammonia. So I start out with 37.42 moles. I also then need to convert the 1,142 grams of carbon dioxide to moles of carbon dioxide, which the molar mass of carbon dioxide is 44.01. Remember, just 4 sig figs. And that gives me a total of 25.95 moles. This is actually 1. Okay, so I put a 25.95 moles here. So I'm starting with 37.41 moles of ammonia, 25.95 moles of carbon dioxide, and none of the product because that reaction has not taken place yet. So first thing I need to do is figure out what the limiting reactant is. If I used up all of the ammonia, so after there was 0, my question is how much of the carbon dioxide would I use? If I don't use up all the carbon dioxide, I know that ammonia is my limiting reactant. So let's check and see proportionally how much carbon dioxide I have to use up. So I have 37.41 moles of ammonia proportionally to X, which is what I'm looking for, moles of carbon dioxide, equal to, according to the stoichiometric equivalence in the equation, 2 moles NH3 to 1 mole CO2. When I do that calculation, rearranging, solving for X, I get 18.71 moles. So what that means is that I have used 18.71 moles of carbon dioxide. Subtracting 25.95 minus 18.7, I get that I have 7.24 moles left over. That means this is my excess reactant, and this is my limiting reactant. Now the consequence of that being my limiting reactant is that that is the one I'm going to have to use to figure out how much product I made. I can also just look at my equation here and see that I have a 2 to 1 to 1 to 1 ratio. So if I used up 18.71 moles of carbon dioxide, I'm going to make 18.71 moles of product and 18.71 moles of water. I can take that 18.71 moles of NH2 I'm going to move that over a little bit. I need to convert that, to grams of NH2CO. So 18.71 moles NH2 H2CO times the molar mass, which is 60.06 grams, and I get that I made using sig figs, 1,124 grams of NH2CO. Now I also wanted to know how much excess carbon dioxide I had left over, so I need to convert that moles carbon dioxide to grams. And the molar mass of carbon dioxide is, molecular mass is 44.01. So I get 318.6 grams of carbon dioxide left over at the end. So this is just one way of solving this problem. Okay, so I use the BCA table to answer that problem. One more thing you need to do when addressing this problem that I sort of did without showing my reasoning for is how I knew this was 18.71 moles and so was this. And the way I did that showed my understanding is that I showed that I knew that the ratio of moles of carbon dioxide to moles of NH2CO to moles of water was 1 to 1 to 1. So that just gives my reader the information that I understood why those numbers were there. So there's also a more mathematical way that you can do this that doesn't involve the table. And it's just as good. And it starts in the same place. So whichever one of these works best for you is the method you should use. I understand both, and so will your AP reader. So NH2CO plus H2O. So here I have my balanced chemical reaction. It's the same place we started last time. And the next step, to figure out the limiting reactant. So we always have to figure out the limiting reactant before we do any stoichiometry. And that's because we need to make sure we're basing our calculations off of the reactant that's going to run out first. So you may recall in class I also talked about how to figure out which one was the limiting reactant without using the BCA table. And that's what I'm going to do now. The limiting reactant is the reactant that produces the least amount of product. So in this case, let's say that I have, I'm given that I have 637.2 grams of ammonia. I want to find out how much that's going to produce. I'm going to erase this for a second so that I have the space I need. So I need to convert that then to moles. 1 mole of ammonia is 17.03 grams of ammonia, and then I will convert that to moles of NH2 too. And I get that I have 18.71 moles of NH2CO from that mass of ammonia. So that was a weird little thing that happened on my computer, but anyway, my goal right now is to find the limiting reactant, so I have converted the grams of ammonia that I have to how much of the product it would make. I need to now do the same thing for the carbon dioxide. If I have 1,142 grams of carbon dioxide, how many moles of product can I make? And it turns out that if I do this, 44.01 and 1 mole, this is a 1-to-1 ratio for my balanced equation, so I know that 1 mole of this product comes from 1 mole of carbon dioxide, so I can make 25.95 moles of NH2CO. You'll notice these numbers look familiar. They're the same numbers that I get in the BCA table. This is just a more linear, non-table way of doing this. So I look up here and I say, okay, which one of these made the least amount of the product? And it was this one. So I know that this is my limiting reactant. So what I need to do next is I need to figure out how many grams of the product I've made. I already know that based on my limiting reactant amount, I can make 18.71 moles of NH2CO. And I need to convert that now to grams. So the molar mass of that is 60.06 grams per 1 mole. And ultimately I get that that's 1,124 sig figs, so I know that that's my rounding, NH2 to CO. Notice that I got the same answer. I'm basically doing the same thing I was doing up in the BCA table. This is just a more linear way. So whichever way works for you, you should stick with. The final part of the question is how much excess is left. Okay, so how much excess is left? Well, I can start by saying I started with my 637.2 grams of ammonia. Convert that to moles, which you may have already done earlier, but I did not actually write it down. And then I'm going to keep on converting to figure out how much of the carbon dioxide I actually used. And it turns out that I can do that then by saying that there are 2 moles of ammonia for 1 mole carbon dioxide. And then I need to convert that mole of carbon dioxide to grams carbon dioxide. And I get 823.21 grams of carbon dioxide were used up in the reaction. So then I take my original amount, 1,142 grams of carbon dioxide, which is what I originally had, and I subtract the 823.21 grams of carbon dioxide. So I have 1,142 minus 823.21, and that gives me remaining product of 318.6 grams carbon dioxide. Same answer I got with the BCA table, but that answers those questions.